Okay, good afternoon, everyone. Welcome to the Network Security Track 2 session. We have a great agenda for you today. We got two speakers. Some of you that might have seen the earlier version of the agenda probably saw that we had another presenter for today, but unfortunately, due to emergency, had to cancel. So we should have plenty of time to ask questions and have a lively discussion, so we're looking forward to that. Okay, our first presenter is Andrei Robachevsky from ISOC, Technology Program Manager. So Andrei, if you are here, can you come up and we could start the session? Andrei? Okay, let's change. Yeah, we can change the order a little bit. Once Andrei is ready and we see him, maybe we can have him start. But Tom Paseka from Cloudflare is here now, so we can change the order a bit and start with Tom, if that's okay. You okay, Tom? All right. Tom Paseka from Cloudflare.
Good afternoon. My name's Tom Paseka. I work at Cloudflare. And the topic today that I'm presenting is called Spoofing and Denial of Service, a risk to the decentralized internet. And with this topic, I want to touch a bit on BCP 38 and how that's a big risk to everyone. So firstly, starting off a little bit about what our network is. We have 102 points of presence in over 50 countries. So we have a pretty big view of what the internet is around the world. And on top of that, we're also a very content-neutral network. We have all sorts of different content on our network, ranging from universities to hosting providers to the largest song competition in the world. With all of this, we see lots of varying types of traffic. And with that, we see lots of attacks. We see up to 1,400 attacks some days, 1,400 different attacks in a single day. With such a broad breadth of customers, it's really a huge amount of scope on the internet that we have. So attacks are a big problem for everyone. It's something that we all need to solve. It's not just my network that suffers from attacks, it could be anyone's network. Over the years, we've seen lots of different types of attacks. Around 5 years ago, we started seeing SNMP amplification and reflection attacks. These were coming from a very large cable service provider in North America who was running SNMP open on their cable modems. Someone was spoofing in and sending a SNMP walk and reflecting it back to me. At the time, that was around 80 gigabits, which was huge at the time. A few years later, we saw what was known as the spam house attacks. These were the very large DNS amplification attacks, which started taking hits at internet infrastructure and impacting a large number of users. And more recently, we've seen the Internet of Things attacks, like the MANRS attacks. They've been direct attacks which we've seen growing over 500 gigabits. So most attacks have a few things in common. One of the first points is that there's a flood of IP packets. This demonstration is not a broken pixel. It is the demonstration of what a real packet looks like amongst a DDoS attack flood. There's 10,000 red dots there and one green dot. The other one is that there's IP spoofing. Often you'll have people pretending to be someone that they're not. And this is a really big problem. Spoofing enables impersonation. If you're able to spoof a different address than you really are, it allows you to impersonate, and that's a bad thing. So why is spoofing so bad? So this is my good friend Walt. Let's say that Walt has been assaulted, but the people who assaulted him were wearing a mask. We can't see who it was. How can we stop them? How can we get retribution against them? You can't. So you need to take off that mask. You need to be able to solve spoofing. So BCP38, it was released nearly 17 years ago. But it's still being talked about and asked, why isn't it being deployed? It isn't deployed. 17 years later, we're still seeing that huge amounts of the internet is spoofable. Kata are wonderful people, and they took over the spoofing project. They have a little daemon you can download from their website, and you're able to test if a network is able to be spoofed. I tested this network about 20 minutes ago, and it's not, so congratulations to the network operators here. Having a look at this, you can see that there is still 25% of internet connections are capable of spoofing. That's really scary. If you're able to get on an internet connection and create spoofing, you're able to cause absolute havoc. And BCP38 described spoofing described ways to fix spoofing. In this example, you show that there should be filtering very close to the source. So at your end users, you're filtering what addresses they can send packets from. So IP spoofing enables impersonation, and it isn't solved. So tracing back IP spoofing, it's impossible. Well, maybe not impossible, but it's really, really, really hard. Where did the attack come from? In this slide, I have a server sitting there connected to a router as is normal, and there is multiple numbers of input sources into that device. Where could it come from? It could come from any of the devices connected to that router. I don't know. So we can go back and do tracing. One of the simplest ways we can do this is having a look at graphs. As an operator, you collect your network interface graphs, you see what's running on it. So there was an attack here. Where was it? Right there. This is a way that many people look to identify attacks. They just have a look at their graphs and say, hey, look, my interface is full. But what does that mean? How do I use that? And what's on the other side of the cable? So from here, I have my router. I have direct peering in it. I have other people who are directly patched into my router. I have a local internet exchange where there is a number of users connected. And I also have an internet carrier, a transit provider, who's providing the rest of the internet. So in direct peering, it's pretty easy to identify what is on the other side of the cable because it's someone else's router who I've authorized them to plug into my router. We know that there is generally that network and that network's customers only behind that interface. What about an IXP? So we're connected to an internet exchange point. There could be hundreds or even thousands of members connected to that internet exchange. How do I know where it came from? How do I know if it came from that person or their customers? It's very difficult to follow. And then if I have a transit port, it could come from anywhere on the internet. There's no way to easily identify where it came from. So internet exchange points, as I just went through, you've got multiple ISPs connected to it. You don't know where it could come from. You have a packet getting injected into the switch. It could come from any number of members, and it arrives to you. And the same deal with the transit provider. You have a source IP address coming across. It could go through 4, 5, 6, 7 different network boundaries before it reaches you. So it's really difficult to find where it came from. And one of the other things we've noticed a lot is we have direct peering with a network. So in this case, we have direct peering with 8888.0/24. But we're starting to see source packets from that IP address, which we're directly connected with, across the internet, across another transit provider. So we know that's spoofed, but where is it coming from? And so all of this gives lack of attribution. Without attribution, how can we follow through with preventing the DDoS from happening again? And so IP spoofing allows sophisticated attacks. Amplification is scary. A 10-byte request in this example is getting amplified 10 times. You've got a 100-byte response. If you have a 10 gigabit connection, you're suddenly sending a 100 gigabit attack. If you're sending 500 gig attack, suddenly you're sending 5 terabits. And I don't think there's any network in the room that could actually tolerate that, sans 3 or 4 globally. And so talking about the spam house attack that I mentioned before that we received, in this case, there was approximately 27 gigabits of spoof traffic being generated across up to 30 million different DNS resolvers. These were then amplifying the traffic to around 300 gigabits of traffic. At the point in time that this happened, it started to cause severe degradation to the internet. It was targeting to providers' core routers as well as internet exchange points, and it caused disruption for many. But amplification is pretty easy to block if you have the bandwidth. And like I mentioned, there's probably 3 or 4 networks globally that have sufficient resources to be able to absorb hundreds of gigabits. In the case of DNS amplification, it's very, very simple. Blocking source port 53 to something that doesn't speak DNS is a very simple block. And there is a lot of industry work happening to block these sources. The Open Resolver project was started immediately after these attacks to identify and start to close down the Open DNS resolvers, as well as the Open NTP project, which has followed on since we've started seeing NTP amplification attacks. So talking a bit about source IP addresses, we've seen here the source IP address is being spoofed across an internet transit link to attack us. So this is a map of the internet from our good friends at XKCD. They make excellent comics and you should all read them. This is showing what is allocated and what is available on the internet and where it sits. So we've used this method to draw how we see attacks. So this is an example of an attack that we've seen directed against us. Each of the dots represents an IP, in the squares representing the /8 that they exist in. You can see from this that we've seen attacks across almost the entire routable internet. But that's likely not possible. It's most likely that this attack was spoofing every IP address on the internet. And this is another great example using the same methods. We've seen on the left is a very large Asian carrier or Asian ISP and their routable address space. And on the right is the source IP addresses seen in an attack. Now this attack may have come from that carrier. Was it spoofed, or was almost every IP inside their net blocks attacking? Were they doing BCP 38 at the edge, or were they just doing it at the actual edge of their network as it's leaving, only allowing their own IPs to exit the interface? So how does one deal with attacks? Like I said, there's very few people in the world who can. Most people deal with it with null routing. It's a very simple process. You contact your ISP, often through a more automated method such as BGP signaling, and tell them not to forward traffic for an IP address. They will then discard that IP address or any traffic destined to it at their borders. The problem in doing this is that you've just let the attacker win. You may have advanced systems where you can change your service IP address pretty quickly, but the attackers can change too. So you're in a cat and mouse game of constantly blackholing your own IP addresses and your own service to stop the attack from overwhelming your resources. So the only way to stay online is to absorb an attack. That means you need to have enough resources to be able to ingest it. You need to have enough bandwidth to be able to transport it, and compute power to receive it. This is the only way that you can do it. But if you're running your own web server at home, that means you have a single server, like most likely. You have your internet connection, DSL modem, fiber to the home if you're lucky. It has a limited amount of bandwidth. If I have access to some spoofing capabilities and I can generate 100 gigabits of traffic, I can take down any residential connection. If I have even more bandwidth and I can generate a terabit of attack traffic, I can take down almost any ISP or service provider. So who has this capacity to deal with it? Not many. And this is a massive risk for the internet. We see that the internet should be decentralized. There shouldn't be 1 or 2 or 3 or 4 companies who can control most of the resources on the internet. But with attacks like this, that's not the case. If you cannot run a service on the internet reliably, that means you need to go to a service provider who can protect you, who can keep your service online. And that number is very, very few when you get into terabit scale attacks. So the solution? Technical solutions for IP spoofing have failed BCP38 is essentially dead. The best common practices group is probably hating me right now, but it just isn't implemented. It's just not there. So from a technical side, we failed. We need to go past this. We need to think of how can I communicate with another network to say, I'm seeing spoofing from your interface to me, you need to stop it. If you don't stop it, I'm going to sue you. Or what is the next step? So don't just solve IP spoofing. Of course, it would be great if everyone out there went out and fixed IP spoofing, but I just don't see it as happening. 17 years later, it hasn't happened. So we need to solve the attribution. We need to come together as a best practice and say, how can we communicate with each other that I'm seeing spoofing from your network, that I need you to react to that? So NetFlow, it's an amazing product. It's existed since the beginning of time as well, but how many people actually run it in their networks? I've spoken to many large carriers, many of the tier ones, and they've said, oh, we don't run NetFlow in our network. I don't believe them, but apparently that's true. But NetFlow is so simple to set up. I believe in the peering forum yesterday, there was a discussion talking about how to set up NetFlow and some of the open source tools. And the open source tool sets are great. They've grown a lot since 10 years ago, and they're very scalable. A lot of people may say, I'm not going to turn on NetFlow because I have privacy concerns. But this is sample data. This is very, very simple data, just including headers. And there's ways around this. You can rotate your logs very often. You can rotate them daily. And you use a very high sampling rate, say 1 in 16,000. You're not really collecting personal data at that point. But also hardware vendors have to get better. NetFlow v9 supports source and dest MAC address. Where I'm talking about an internet exchange, I can then see which member on that internet exchange was sending the traffic because I can see the source MAC address. But which vendor supports it? None. None of the major vendors support MAC address information in NetFlow v9 or IPv6 or similar. It's really disappointing. And it's also embarrassing that a transit provider doesn't know where packets ingress their network. We've had a connection with a network that we peer with, and we've informed them saying, hey, we're receiving spoof traffic from you. And they're saying, oh, we can't determine it. I give them the time frame, I give them source IP, dest IP, all of the information which would normally be required to track it down, and they say, oh, we don't run NetFlow. And so that's an embarrassment. And like I mentioned, it's also embarrassing that hardware vendors don't support full NetFlow v9, and this needs to be resolved now. So this is the first step. Attribution allows informed discussion. If we were able to attribute the attacks, we'd be able to identify where all of this traffic is genuinely coming from. We'd be able to openly discuss it. We'd be able to work together and say, we won't support networks that act like this. Because DDoS causes centralization. When you have an attack to this scale, there's very few people who can deal with it, and that causes you to go to a service provider who will deal with this, but that means you're losing the decentralized nature of what the internet is. To fix DDoS, we need attribution, and we need that to make the internet better for everyone. Thank you.
Thank you, Tom. Are there any questions for Tom? Any proponents of BCP38 that want to say something? Okay, I have a question. Tom, you mentioned only a few networks are able to absorb these. The only thing is to absorb it, and only a few networks can do it. And you're a security company, and I think you guys do Anycast on the network. Have you been able to absorb? I know you reactively work on things really as they happen, and you see them every day. But have you got to the point where you're not able to absorb, or there are periods of time that you have issues until you're able to remedy it?
Yeah, I think there isn't attacks that we've seen yet that cause us to worry. We're able to ingest any attack that we've seen. Usually what we see is that there is collateral damage on the internet before we're really impacted. So you may see that interconnections between providers gets full and you'll have thousands or hundreds of thousands of end users being impacted before we congest our pipes and our service runs slow.
Okay, thanks, Tom. Anyone else?
Adley from APRICOT. With the attention given to Mirai, people are saying that attacks are going towards the direction of non-spoofing. Do you see this as the next big thing?
Yeah, we do see that non-spoofing is a big issue, but from what we've seen, the size of the IoT attacks is sort of capped out at the 500-600 gigabits. But what we have seen is that these botnets are actually capable of spoofing. So with the Open Resolver project, you can have a look, and there's still something like 19 million OpenDNS resolvers out there, which are capable of spoofing. So if I can generate, say, even 100 or 200 gigabits of that IoT botnet as spoof traffic pointed at those, it's the end of the world. Like, this is as bad as it can get for attacks.
Hi, Christos Papadopoulos, Colorado State. So you say that attribution is important, but what is it that will compel the source network, the one sourcing the attack, to actually react when you point out that an attack is coming from them?
So there's multiple methods. One is name and shame is one of the most common ones. Beyond that, there's legal attribution that can follow. A DDoS attack is in the US is technically trespass. And that's very easy to follow through as long as there is attribution. But if you can't attribute it, then that's pointless.
Okay, anyone else have any questions? Okay, Ray.
Hi, Ray from APRICOT Design. So, is there any? So, how's Cloudflare doing when to prevent the spoofing and the hijack? Yeah, could you share a little bit more?
So, I mean, BCP 38 gives the guidelines of how to prevent spoofing. The problem is that many networks don't implement it. That in itself is the simplest way. As for hijacks, that's a problem which hasn't been solved as yet.
Thank you.
Okay, anyone else? If not, I think we're doing pretty good on time, so at the end, if you think of any other questions till we get to the end, we can pose questions to Tom at that time as well. Okay, thank you, Tom.
You.
Next, we have Andrei Robachevsky. I think I saw him walk in just a little after we started. And he's going to talk about 2 years of good manners and the recent updates on those issues. Okay. Thank you. Yeah, just these left and right. Yeah. Thank you.
Hi, good afternoon. My name is Andrei Robachevsky. I work for the Internet Society. And today I would like to talk about routing security. Routing security and the initiative that was launched 2 years ago, which is called MANRS. I wonder how many people here in the room heard about this initiative? Okay, well. So I'll tell you about this initiative anyway, because there were many people that haven't heard about that. So what problem does this initiative try to address? It's a problem of BGP as a protocol. And I don't need to tell you, I think you know this better than I, that the vulnerability of the BGP is that it's really based on trust. There's nothing in this protocol that allows you to validate the information you receive from a third party. And this chain of trust spans continents. So it's even more difficult to trust someone who is many hops away from you, who originated this announcement in the internet. And another thing is that the BGP operates, or this trust should be supported by data which is out of band, which is not part of the BGP protocol, which should exist elsewhere, against which you can validate information you receive through BGP. And maintaining this data, it takes time, resources, and diligence. Do we have enough tools? I think yes, I think we have tools. We have practices on prefix ICE path filtering. We have tools and databases to keep the data. IETF doing a great job on developing technologies. RPKI is a developed technology as far as IETF is concerned, and BGP is very close to, BGP-SEC is very close to completion. We have various registries, WHOIS, and so forth. So in principle, I think we have a solution. We can solve this problem today. But if we look at whether those techniques, tools, technologies widely deployed, well, I think here you see a stream from BGP Stream. That's a tool that listens to different BGP announcements all around the world and tries to detect suspicious events in the global routing system. And this is a huge list, and if you look at daily statistics, there are many, many events happening in the internet. Some of them may not be attacks or malicious events. Some of them may be legitimate configurations, although BGP Stream has some heuristics that tries to filter this out. And some of them are fat fingers, and some of them are genuine attacks. So we have the tools. What's the problem? And the problem is a social economic problem. That's not a technical problem, really. One thing is that from a routing perspective, you cannot really secure your own network, no matter what kind of technologies you deploy. Security of your network from a BGP, from routing perspective, is in someone else's hands. So we need more hands. The more people take care of your network security, the more secure your network. I think you need to do the same, so it's sort of reciprocity that exists here. But also, is there a clear industry support line between good and bad? I'm not sure it is. The thing is, we have best current practices and they aspire to good solutions and good behavior, but really when you read this document, you don't know to what extent it's supported by industry, to what extent it's deployed by the industry. Well, we just heard a presentation on BCP 38. It's a practice that existed here for more than 1 decade, almost 2 decades. How many ISPs are supporting that? So if you blow this line, it's now not clear whether doing anti-spoofing is a good thing and not doing it is a bad thing. So it reduces peer pressure. So we need sort of a defined cultural norm beyond which is bad behavior and above is good behavior. And those two things MANRS, this initiative, is trying to address. So it defines a clearly articulated baseline, a minimum requirement. It's not a best current practice, unfortunately. It's a minimum current operational practice. And it also tries to demonstrate visible support from the community with commitment. So with this intro, what is MANRS? So MANRS stands for Mutually Agreed Norms for Routing Security. It defines 4 concrete actions that network operators should implement. Network operators who want to join this initiative. Although the actions are pretty technical, they're technology neutral at the same time, because MANRS doesn't intend to promote specific solution. I think this is 1 layer down, but it looks at the outcome, what we want, how we want the good look like. And the second thing, back to my previous slide, is it tries to draw this line between good and bad by building a visible community of security-minded operators, and thus promoting the culture. So why people need to get together? Well, one example is Comcast, and this is a US broadband provider. Comcast has implemented these actions in their networks, but they felt that, well, still part of their security protection is in other people's hands. So they were very interested in bringing other operators together and developing these norms and this initiative. So what are those good manners? It's filtering, preventing propagation of incorrect announcements. It's anti-spoofing. Again, we just heard a presentation, but we're still attempting to inject this practice in this initiative as well, is to prevent traffic with spoofed source IP addresses. It's coordination, which means facilitate operational communication and coordination between network operators. Be sure that contacts are up to date and they are responsive. And finally, global validation. It's to facilitate validation of routing information on global scale. Well, some of you may look at this and say, well, this is motherhood and apple pie. I mean, what's news? Well, the thing is, this set of action, this package, if you look at the document itself, it's optimized for low cost and low risk. So this initiative is not trying to boil the ocean. It really defines the first step where most of the ISP should be should be able to easily made. Just one example, for instance, when we talk about filtering, we talk only about your customers. So please consider your customer cone and filter announcements from there, because you should know what you should receive from your customers. Anti-spoofing, well, there is certain at least perception, but yeah, there are cases where techniques like BCP38 and like URPF are difficult to implement. But there are simple cases where you have a single home stop customer where that should be very, very straightforward. So this action actually talks about those cases. So if you have those cases, and I think, you know, many, many networks have this simple setup, please go and implement that. I talked about coordination. This is about contacts, right? Simple thing that even that thing is not always kept up to date and contacts are not always responsive. Although that's extremely important when you try to address an incident or you try to mitigate a denial of service attack. And finally, global validation. It's not about that you validate globally. I think many networks are not prepared to go that far, but that's about providing information for others who wish to validate so they can do that. So you publish this information and keep it up to date about what others can expect from your network with regards to announcements and routing policy. So MANRS really addresses this simple topology. Those are the actions. This is the scope of those actions. This is one network in the center, this was black circle. That's the network in question. It has a few customers, single home stop customers. It has one or two peers and an upstream. It's a typical setup, but this setup is prevalent in the internet. So if we can implement this building block and implement this widely, we'll see a significant improvement in the state of routing security. So it's not only a document, it's not only a web page or minimum current operational practice. It's also a commitment. So anyone who wants to join and say, yes, I support MANRS, it's not just I think routing security is important and I'm willing to put my signature under this document. You have to implement and you have to demonstrate that you implemented those actions. So that's a commitment. And more, you need to take on board and go and promote these MANRS, promote those actions and this initiative. So it's not a firewall. If you join MANRS, your network probably is not more secure because you already implemented those things. But I think by joining, by showing support for this initiative, you motivate others to do the same. And that creates this positive loop, hopefully, that creates a cultural change. So ultimately what we want to build is create MANRS as a mark of quality that will be recognized and will be respected and will be, I mean, many more operators will be interested in. As I said, it was launched 2 years ago, slightly more than 2 years ago, by a group of 9 network operators. Some of them you may know. Since then, we have grown. So we have a list of participants, and that's how MANRS webpage looks like. That's a list of participants supporting this initiative with 4 actions where they do the ticks. In order to join this initiative, you don't have to support all 4 actions, but most of networks support all 4, and others support 3, but none supports less than 3 actions. So let's look at the statistics. 2 years of good MANRS. I think we grew quite rapidly in 2014, and that was low-hanging fruit of network operators understanding the concept, understanding why joint action and demonstration of this joint action is important. We see slightly less growth in the coming years. And now we're about 90 operators, about 40 operators covering more than 90 networks all around the world. 23 countries, I think, part of this effort. But if you look at the internet, well, internet is much bigger. I mean, it's about 56,000 networks there. So how does this compare to this effort? It's like negligible. Well, yes and no. So if you really look at the internet, we know that it's about 8,000 networks that do real routing. The rest are just stub ISS. So if we can convince that 8,000 networks to join MANRS, I think our job is done. Oops. So that's the aspiration of this effort. Still a big gap, right? So how much time, if we go with this pace, it will take before we get to that point? So I think we need to think how we bridge this gap. So what we are working together with the operators, when I say we, I have to say upfront, it's not an ISOC project. ISOC is playing just as a platform, just as a coordinator, secretariat of this project. When we say we, I mean the members of this initiative. So what we are planning to do is we're planning to increase gravity of this activity, put more activities, create MANRS not as a web page, not just these 4 actions, but as a platform where security-related activities take place. One of the things that we did last year, we completed a document, development of the document, which is called Implementation Guidance, a MANRS B Corp document that is now published, and you can download and read it. One thing is that, as I said, the MANRS document itself, if you go to the website and read the document which explains the 4 actions, it's pretty high level. It's technical, but pretty high level. It doesn't give you real guidance how to implement this stuff. And many networks need this guidance. So it was decided, let's create this document, right? And when we start working on this document, we thought, okay, well, let's create a small, short document with practical instructions, 1, 2, 3, 4, 5. You implement all the actions, here you go. Well, now it's 50 pages document, and then not all of them are 1, 2, 3, 4, 5 instructions, which talks about security is hard. It's hard. So we're thinking about potential training and certification program. So if we can develop some training materials, again, to help people to understand how those actions can be implemented and make them more confident and stimulate them, I think we can get much more traction. Another thing is expanding, broadening the initiative, bring new types of members on board. Right now, it's limited to network operators, but there are other parties. For instance, internet exchange points. They are locus of different activities, community activities, also security related. So they might be a very interesting partner in this game. maybe even vendors. I mean, we know that some of the things cannot be implemented because vendors do not support it, because vendors have no capacity or equipment doesn't have enough capacity to implement those measures. So bringing vendors on board with their commitment could, again, help this effort. We need to develop a better business case. So this sort of reciprocity and peer pressure, it's all great and super, but I think if we can engage market forces here, we can get much more traction. And market forces, they come bottom up. It's your customers, right? If we can make your customers or your potential customers interested in MANRS, saying, hey, you know what, with all other things equal, I would rather choose a network provider that is MANRS compliant, I think we can get much more energy in this effort. And of course, the ultimate goal is to create a trusted community of network of security-minded operators that can expand their activities, think broader than just routing security, perhaps. Let me maybe tell a few words in more detail about two things, the training activities and the how we plan to bring IXPs on board. So training and certification. As I said, routing security is hard. It's unfortunately not a one configuration parameter in your routing configuration or router configuration. It's not, you know, software upgrade that can make you secure. Really, MANRS, in order to implement simple things like prefix filtering, you need to understand different systems. You need probably understand even different languages. Like if you want to use internet routing registry, you need to understand RPSL. If you want to use RPKI, you need to understand this technology. So that's a learning curve. That's not just one switch, security on. So we resulted with 50 pages document, which still needs additional support. It still assumes certain level of knowledge of those who read this document and try to implement this. So how can we make it more accessible? Well, of course, training comes to mind. And I think MANRS BCOP is not just, it's not the whole network security, it's not the whole BGP security. In order to secure BGP, you need to do more than MANRS. MANRS is, don't forget, it's a minimum norm. So we're thinking how to integrate this minimum baseline into training that other organizations are delivering. So we are looking here for partners to see if we can work together and somehow articulate MANRS while giving a wider and more comprehensive training on network security and routing security. And hands-on is important. So right now what we're doing, we're developing a series of online modules that people can follow online to understand how to implement different actions, but also we're thinking of either developing in partnership or ourselves a hands-on laboratory that can help people to really configure this minimum baseline in their network as a first step. So bringing internet exchange points on board, we call it IXP Partnership Program. So the result of synergy, and well, we had discussion with different IXPs, there is synergy. First of all, IXPs have community, and in all those efforts, in MANRS effort, community is very important. They have community with common operational objective that brings really people together. And the thing is, in our world, there is no such thing as global community, right? It's eye contact that makes a lot of sense. It's business relationship that bring people together. So IXP really have this community, and they can, notion of sort of safe neighborhood I think it's not foreign to them. And you need to start somewhere, right? You cannot boil the ocean, so you have to start cleaning your part of the street or your part of neighborhood. So IXPs can be very, very important partner here. Now, MANRS, again, it comes with commitment. It's not just, oh yeah, we support this, and we can put your logo on, our logo on your website. It's about commitment. So what is important here is to understand how IXPs can usefully contribute to routing security, and develop a set of actions that IXPs can commit to and become members. It might be the same set of actions that are valid for network operators with maybe slightly different interpretation, right? For instance, preventing incorrect routing announcements can be done through a route server that many IXPs are running. But right now, there is a group of IXPs forming development team, and they are looking at just what really trying to answer this question, how IXPs can usefully contribute to improvement of the routing security. Maybe technical measures, some tools, monitoring tools, but maybe also social measures, right? They have meetings and they can promote this activity among their members one way or another. So this work started, and I hope that will bring either new category or new category of players in this field into this initiative. To finish up, well, I hope the network operators that have already implemented MANRS, I'm sure there are many of those, and if you would like to set up and demonstrate your support for this initiative and your commitment, please go to this webpage and sign up. It's easy. We do some checks. So we're trying to check compliance, although, in some cases we need to trust people, and we have some dialogue to understand whether it's indeed implemented as such. We do some checks, like background check. We ask people to run spoofer to see if the network is spoofable or not. We look at different databases to see how contacts are published, if information is up to date, and how comprehensive it is. And if it's all right, you will be added to the website, you can download the logo, and you can become part of this community. Yes, I think that's it. Thank you.
Thank you, Andre. Thank you very much for that very good presentation. Are there any questions for Andre? I do have one. Andre, you mentioned that some of the points to try to get more people involvement in the MANRS program. Has the community done any targeted type of recruitment? I know it's growing really well, organically by just the community, and over the past 2 years we have good growth. But is there any targeted reactive type of recruiting? Let's say we notice specific networks that aren't filtering properly, or they're announcing bogons, or doing something that if we target them and try to get them included, that maybe they'll serve as an example to a group, or to a region or something that might not have as much representation. Do we also, besides the organic growth, do we also do some kind of targeting, more kind of forceful type of?
Thank you. That's a good question. Well, quite frankly, we didn't. Well, our target was on networks that have already implemented MANRS. So, sort of presentations that we're doing is convincing why, if you already implement this stuff, if you already feel yourself sort of up to scratch and much more than MANRS, why you need to sign up to this initiative. And hopefully we're getting some traction there, and the more people we get that do not need to spend money to implement MANRS, right? They just need to show their commitment and support. That's our first step. That is the phase we are in, right? So we're recruiting from that group of people. We also trying, what I said, build a business case. So we're trying to put some pressure and engage market forces from the sort of enterprise customer size to understand what sort of, do they at all understand the issue of routing security? Do they at all value if their service provider implements certain controls? Because if they're not, I mean, how do you create this market pressure there, right? So we will try to articulate this issue more, and we will also try to see what those customers value from their provider, and that might again affect the MANRS. We can maybe add another action, for instance. I don't know, DDoS mitigation. So it's a good question, but I think we are still in the phase where we're trying to recruit from this group of people that are good citizens, that understand those concepts and are willing to support this initiative. But of course we want to go further.
Great, thank you for the reply. Thanks.
Thank you. Thank you.
Thank you all. Tom, do you mind coming up and stay there, Andre? Just a chance for anyone for final questions for Tom and his presentation, or Andre, his presentation? Don't be shy, we got a lot of time. Okay, well, you can catch them if you have some questions later. Please give them a round of applause. They get, thanks. Okay, I think we're okay until 6 o'clock. You guys have extra time now. There'll be a BOF at 6 in this ballroom. Okay, thanks everyone. Thanks for your time.